Pre-calc lecture video for lesson 122, graphs of rational functions, graphs that contain holes. I hope we've talked about rational functions before with asymptotes and stuff. I feel like we've graphed some by hand before. Basically, I'll go through the highlights right here. It says the zeros of the numerators are the zeros of the function. So what does that mean? That means when this is all factored in the numerator, those, like if you use the zero product property on them, there's going to be, that's where the graph is going to cross the x-axis. Those are the zeros, okay? And then, well, it turns out these, now that's the numerator. Those are the zeros, or where the graph crosses the x-axis or intersects with the x-axis. Now these down here, the like if you use zero product property on this factored form down here, then you're going to get asymptotes. Vertical asymptotes come from these numbers down here. Okay, so here is the basic rule that allows us to be able to graph these things. It says, since a rational function that is composed of unique non-repeating linear factors changes signs at each zero. So it says unique non-repeating linear factors. That means factors that have a multiplicity of 1. Because you know, if you have a repeating factor, if it has like x plus 1 times x plus 1, then it just bumps the axis at -1, the x-axis. But if you have non-repeating linear factors, then we know that the graph is going to change signs at every zero of the numerator. The graph, you'll see what I'm talking about once I graph one. It's going to change signs. So in other words, it's going to cross the x-axis, right? And that's what makes it change signs. So the graph must cross the x-axis at every zero, and it jumps across the x-axis at every pole. So it turns out that the denominator, the zeros of the denominator, after it's all, like if you have a denominator like this, and it's all factored like that, the zeros of the denominator in this one are going to be -5, -2, +2, and +5. That's going to cause these vertical dotted lines here. That's this denominator, all the zeros of the denominator cause the vertical asymptotes, and it should sort of make sense because we know you can't have a zero denominator. Well, the number 5, if I put it in right there, that would give me a zero denominator. So the graph, so there has to be like an asymptote there so that the graph doesn't go there, because we can't have zero denominators. Okay, so it says it in that other paragraph over there, it said it's going to jump at every pole. These asymptotes are poles. So if it disappears up this direction, when it comes back, it's going to come from the opposite. Like if it disappeared positive, it's going to come back negative. And then that right there was a zero of the numerator, so it'll go through. And then when it disappears up here, it reappears down negative. If it disappears positive, it reappears negative, because it has to change signs at every pole. That's why it does that. So let's see what else we need to know. Graphs that have holes. So we don't end up having to graph one that has a hole in it, but I can tell you what causes a hole. When you have, here, let's look right here. See how we have the same factor and we can like cancel out in the numerator and the denominator? That creates a hole in the graph. Kind of like, see how that has a hole in it? So you can't have a value because there's the, well, in this case, the 3 would make a zero denominator. See, there's that one. 3 would make a zero denominator there, so you can't have a value there. But this factor and this factor cancel out. So it just, well, you can read this right here. So it just makes there be a hole in the graph rather than an asymptote. So basically, if there's cancelable factors, you get a whole rather than a vertical asymptote for that bottom, for that denominator, the 0 of the denominator. So you can look down here. These two right here are going to cause a hole. And see, there's the hole. Oh, wait. Positive 1. What? Oh, here's the hole. Right there, positive 1. Okay, I'm going to do number 6. I've got a few more minutes. So number 6, it's already all nice and factored for me, so I can see that there's going to be a 0 at -1 and a 0 at 2. So on my graph, I kind of messed up. There's my 0 at -1. That was a mistake. And there's my 0 at 2, so I always just make like a dot on the x-axis where my zeros are. And then those are zeros. And then over here on the denominator, if I use zero product property on this denominator, I have as x is 0, x is -3, x is -2, and x is 4. Those are all asymptotes. They don't cancel out with any of the factors in the top. So then I just go ahead and I pretend I still have a blank graph and all I've got is these two dots here. Then I go ahead and fill in my asymptotes. I put one along the y-axis. And then I put one at 4 because of that 4, and I put one at that's -2 right there, and I put one at -3. And then what I do, so at this point, I know I already have it drawn because it's hard to draw and hold my iPod at the same time, but at this point, imagine I don't have these lines drawn yet. I go to the far right, that's where I start, and then I ask myself, would this, in the far right, that's when x is largest. So I imagine like if x were 100 or some giant number, what kind of fraction would this be? Would this be a positive fraction or a negative fraction? Well, I don't see any like negative signs that are going to cause this fraction to be negative. And I know if x were a giant number like 100 or more, I know that we'd have some big number, some, you know, x squared something number up here. But then we'd have x to the 4th down here. So that would make it, the denominator would be so much bigger than the numerator that it'd be very close to 0. So that's why it comes in from the right and right above the x-axis. But then when it sees the first asymptote, it can't keep going. It can't go through 4 because that would make a 0 denominator. So it just has to follow the asymptote on up. Now remember, it's going to change signs at every pole and every 0. So this is a pole or an asymptote. So it has to change signs. It just left in the positive. It is positive up here. So it has to come back in negative. So it's going to come down here. And then it looks for a way to get through. It would turn around if it wouldn't have seen that 0 right there. That 0 came from up here. These are the places where the graph actually crosses the x-axis, so it has to cross the x-axis at 2 because of that. So it's coming on along its way, and then it crosses the x-axis at 2, and then it keeps going, but it can't you know, keep going because it can't cross the y-axis because that will cause a 0 denominator. So it just keeps following up, up, up. If it disappeared up, then it's going to reappear back down on the other side of the x-axis. So then this comes up, up, up. It has to cross the x-axis at -1 because that's a 0 of the numerator. So it crosses and it follows the asymptote up. It disappeared up, so it has to reappear down. So now it reappears. And it wants, you know, it follows it up, 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 but it can't come through because there's no hole. I mean, there's no 0 there. So it turns back around and goes down. It disappeared in the downward direction, so it's going to reappear up here. There's no holes and there's no asymptotes to bar its way, so it's just going to continue on that way. And since the numerator is a smaller degree than the denominator, the x-axis kind of serves as an asymptote as well.